So we have a prove question, and it's also starred, which is shouting out at us to explain every step that we take. So we look at the information, and they're telling us to deal with squares of consecutive odd numbers. So these prove questions, when they're giving you information like odd numbers, multiples of, it's about algebra, and it's about creating a line of argument that will get down to something with the 8 times table in it, because of the multiple of 8. So the first thing we need to remember is what's the rule that creates odd numbers. So in other words, what's the nth term rule of odd numbers. So if we look at the series of odd numbers 1, 3, 5, 7, 9 and so forth, we can see that the nth term rule can quite quickly be worked out by looking at the pattern. It goes in twos, so that tells me the nth term rule will involve 2n, 2 times the term number, and then when I write out the 2 times table, I find that to get from there to there I have to take away 1. So that's the general nth term rule for odd numbers. So in a proof question, I'm going to be using that to prove that by the time I've done all the manipulations, I end up with something to do with the 8 times table because of the way the question is worded. They want a multiple of 8. They're talking about consecutive. Well, we've got to remember that consecutive means follows next. So 3, 5, 7. They're all consecutive. They're the next odd numbers on. It's talking about consecutive odd numbers, so 3, 5, 7 and so forth. So if I define, so I'm going to say let the first odd number be 2n minus 1, then the next consecutive, again we're explaining what's going on, so the next consecutive odd number must be 2n minus 1 plus 2. Next consecutive number, we add 2 to get the next odd number. So when we simplify that, we get 2n plus 1. Now the question said, do you want the squares of consecutive odd numbers? So basically it's saying you want the square of the second consecutive number, take away, because it says the difference, first odd number. So basically I've got to prove that that gives me a multiple of 8. So classic thing is we've got to multiply out a bracket squared, so we've got to realise that that means 2n, 2n, so we're going to end up with 4n squared plus 2n plus 2n plus 1, and then from this one 4n squared, take away 2n, take away 2n, plus 1, minus 1, minus 1, multiplied together, then we end up with positive 1. So this comes down to 4n squared plus 2n, well I've got 4n there actually, so plus 4n, let's simplify it, plus 4n plus 1, that's what the first one squared gave us, and we're subtracting what this one gave us. So again we substitute through, so 4n squared, these two can come together to make negative 4n, so negative 4n, and then we've got a plus 1. So 4n squared, take away 4n squared, well they've cancelled each other out, 4n minus minus 4n, so that gives me 8n, and 1 take away 1 is nothing. So all of this has come down to 8n. So just let's recognise why that worked. 4n squared take away 4n squared is 0. 4n minus minus 4n becomes 8n. And then we've got 1 take away 1, which is 0. So that's what the difference of the square of the odd numbers gave us. And basically we conclude, don't we? It's a start question. So this shows that for any value of n, the answer is a multiple of 8, as 8n is the general rule for the 8 times table. So the proof question's not too bad really in a sense. You just got to realise that there's some basic things to know, and we need to realise that the odd numbers can be represented by the rule 2n minus 1, and then it's a case of just taking the information and breaking it up into the bits. Square one of the odd numbers, difference means take away the other squared number squared, work out what all that gives you, and it cancels down to A10, which is a multiple of 8. So proof done.